In 5.4, they cover all of the trig graphs that we have not covered yet. So we're breaking this up into 2 days. So on the first day, we can focus on, so on day 1 of 5.4, the section is called just more trig graphs, right? We did sine and cosine. And then the more is going to be tangent and cotangent that we'll cover today. And then the cosecant and secant that we will cover tomorrow. Okay, so we're going to identify the period and we are going to graph these trig functions. When you are graphing the tangent and the cotangent, there are certain parts of the graph that we're going to focus on. Okay, you have these two functions. These are the forms. And then notice to find the period now, instead of doing 2 pi over k, it's just going to be pi divided by the k value. So the graphs of tangent and cotangent have vertical asymptotes, which have appeared in several of our graphs this year. So I'm asking you to think about what values do you think these occur at and why. So what do we think? When do vertical asymptotes show up? Why don't you talk to your elbow partner about it and see if we can come up with some good stuff. Okay, so what values do you think these occur at and why?
I think you're right.
All right, what did we come up with? What values do they occur at? Where what happens? Yes, where undefined values is when you have vertical asymptotes. So when you're calculating tangent, you want to find where the values are undefined for tangent on the unit circle. So let's think about the unit circle here. If you calculate the tangent, you do y divided by x. So what would make this undefined? Yeah, where x is equal to 0. Yeah, good, when you divide by 0. So what value would that be in radians on your unit circle? Yeah, what was it? Where? At pi over 2, great. Okay, because at pi over 2, you have 0, 1. And then the other point where you have 0 for x would be 3 pi over 2. Okay, so for the parent functions, these tangent asymptotes, the first one appears at pi over 2. What's the distance between these? Pi. Okay, so they start at pi over 2 and they occur at every pi unit. Normally you'll see this multiplied by the value of n. And then you'll have this stipulation that says where n is an integer. We used that last year when we talked about these. We will use it again this year. And then for your cotangent, you do x over y. So we want to think of the values where y would equal 0. Okay, so we're using our unit circle as our reference. Okay, this is at 0 or 2 pi. Pi, if you want to say 2 pi as well, you can. Okay, and then if you do 0 plus pi n, it's just pi n. Or you could do pi plus pi n. That would be fine too. Okay, so when we're looking at our graphs for the one period of the tangent, we want to locate some special points on there. So the period is pi. notice that you do have a vertical asymptote here at pi over 2. You have one at negative pi over 2. And then we are going to focus on 3 points for each cycle. Okay, so this says what other points are simple to graph for tangent and cotangent. We're just going to cross out the other at the bottom there. Okay, so what points do you think are going to be simple for you to graph on this? I'd say probably 0, 0, right? Okay. What else? At pi over 6, what's the tangent? That'll be at pi over. At pi over 6, what's the tangent value? Root 3 over 3. At pi over 4, what's the tangent value? 1. At pi over 3, what's the tangent value? Root 3. So which one of those would you want to graph? The 1. Okay, so at pi over 4, you're going to be at 1. Okay, and then the third one that we're going to graph is at negative pi over 4, where we're going to be at negative 1. Okay, so as we graph these, that's what we're going to focus on. These 3 points for each cycle. Now this here is one cycle. This is one cycle of pi. If this is one cycle, how many cycles are visible in this second figure here? 3. Yep. So this is 3 pi, 3 cycles. All right, and then for the cotangent, let's do y equals the cotangent of x. Period is still pi, but you are going to notice a few differences. So this one is going to curve up from left to right. This one curves down from left to right. 0, 0 is still an excellent point to graph. And then at pi over 4, you still have 1. I'm going to put pi over 4 here because it'll go first in your graph. And then the next one would be 3 pi over 4 is negative 1. Okay, you won't have to memorize the second point. When we start graphing with patterns, you're going to recognize it right away. And then on your graph, you might notice that you can see the x equals pi asymptote here, but the other one overlaps with the x-axis, and so we're going to put that on as well. Whenever you're doing the asymptotes, I'm going to have you use your dash line. You won't have to label every single one as x equals. You'll just be labeling the graphs like we have been. So again, this is going to be one cycle of pi. And then from negative 3 pi over 2 to 3 pi over 2, you see 2 complete cycles together, but this is half of a cycle and another half. So it's still going to be 3 cycles of pi each. Okay, so this is 1, 2, half and half makes 3. Okay, 3 pi. So the points that are simple to graph that we are going to be putting on our graph is going to be where you have your x-intercept. And where the y value is either a positive 1 or a negative 1. Now that might change if you have a vertical stretch or compression. Yep. Oh, yeah, thank you. Yes, for that I put 0, 0 like we did before, but obviously it is not there. It's at pi over 2. Thank you, Mr. Penn. Yes, so you have your x-intercept. At pi over 4, you're at 1. 3 pi over 4, you're at negative 1. Thank you. All right, so when you are graphing, you're either going to be referencing this page as you are doing your homework until you get more comfortable, or you are going to be using the information that we're going to organize in this table here. So I'm going to show you my graph so you can fill this out without flipping back and forth. But the x-intercepts on the graph of the tangent function, we're going to use that 3-cycle graph, and then for the cotangent, we'll do the same thing. So I just want you to list all of those intercepts, okay, that you see on the front side. Okay, so at the first graph, the x-intercepts you should see are negative pi, 0, and pi. So write those down. Negative pi, 0, and pi. Okay, for the second one, you should have negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. So we're going to be using the parent functions to help us with those transformations. Again, anytime you graph, you are going to graph with 3 points. So the other points you would graph would be here at 1 and negative 1, 1 and negative 1. Okay, so you're always going to be using those 3 to help you curve them. Okay, we'll also be talking about other requirements you need for those. Okay, so for your tangent, you should have negative pi, 0, and pi. A lot of times, we'll pick a place where they're starting from. So there, they start at, I usually do the first positive one. It starts at 0 and repeats every period. So every period, you're going to have one of your intercepts. And then same thing for the cotangent. Again, I usually look and see where it's positive. So the first place where it's positive for cotangent is pi over 2. And we use that to create our pattern. Now for the parent functions, they repeat every pi because that's the period for the parents. We are going to be graphing lots of different transformations today. And with different transformations, there's going to be a different process to follow. So in order to kind of keep things organized, we're going to talk about how to find the asymptotes and how to find the x-intercepts. So in your work, you'll always need to identify 3 of your asymptotes, 3 of your x-intercepts. And you can use these equations to help. Other times it might just be easier to use some kind of shift. So we'll talk about that as well. So for the tangent, if you're finding the asymptotes, you can use pi divided by 2k plus pi n divided by k. And for the cotangent, you can use x equals pi n over k. Okay, just remember that everywhere in this table, okay, this is going to be where n is any integer. And we are going to be plugging in integers. Okay, and then for the x-intercept is just take your original x-intercept that you find, and then you do the period times n. So if you want, you can write that with the equation in there. So you can do like pi over k times n, that would be fine. But a lot of times you find the period first. Okay, and so if you're finding the period first, you can just plug that in. But both of these are the same. Once you find the x-intercept, okay, you're going to apply the period to those. Okay, when it comes to the x-intercepts, a lot of times we're going to talk about what the x-intercepts are in the parent function. So if you want to write down what the x-intercepts are for the parent function so you have it all in one place, you can do that. I think it's helpful to just put it in this box because, like I said, the first few times you're going to be using those. We only have to do 3 for each. So for the cotangent, you don't have to worry about the negative 3 pi over 2. We can just take those 3. And then as we're working, we'll be referring back to this, okay? So one thing we have to know is that vertical stretches and compressions, those do not affect the period or the x-intercept. When you're looking at the equation, okay, that is going to be the A value. So a vertical stretch or compression is the value of A, which for sine and cosine, it was always the amplitude. But remember, the amplitude is half of the distance between the max and the min. What is the max for a tangent? What's the highest value it goes to? Infinity, right? Okay, so you can't calculate halfway between infinity and negative infinity. I know it feels like it should be 0, but so you can't calculate what that amplitude is. That's why we don't have to find the amplitude for these. Okay, but if you have a horizontal stretch compression, or even a phase shift, which I didn't write on there, but we are going to deal with those, that is going to affect it. Okay, that's your K value. So you're going to notice when the K value changes, we're going to have to do certain things. Okay, so a horizontal stretch or compression, that will affect those values, and then also a phase shift is going to affect those values. So your directions just say find the period and graph the function. For your homework, you're going to have to identify different things given in these steps. So you're going to have the period, you're going to have to say what the x-intercepts are, the asymptotes, and then where that other special point is. And we'll go over strategies for how to find that point as we work through different transformations. So we have y equals 1/4 the cotangent of x. Do you know what kind of transformation that is? It's outside, so it's vertical. So if it's vertical, it's going to affect the y values. What's your value of k here? K is always in front of x. 1. Okay, so your k value is 1, your a value is 1/4. So the a value, okay, does not affect the period or x-intercept, it affects the y values. So we'll talk about that in a little bit. If you're identifying the period and your k value is 1, okay, pi divided by k is just pi over 1 or just pi. You can jump right from here to here when you're doing that on your own. Okay, but the only thing that's happening here is the y points are going to be multiplied by what? 1/4. So that's the only thing that you have to worry about in terms of changes, which means the x-intercepts are going to be the same as the cotangent. So I'm not going to have you go through the process of finding the x-intercepts when your k value is 1 because they're just the same. Okay, so they're the same because k equals 1 and there's no phase shift. So if there's no phase shift, there's no change in k, all you have to write down are your x-intercepts of cotangent. So if you look back in your chart, we wrote them down here, or you can write them out from here. Okay, so you have negative pi over 2, pi over 2, and 3 pi over 2. Okay, so on your homework, you'll just need to identify 3 of your x-intercepts. for that step. And step 3, for the asymptotes, you can use your equation, and then we're going to plug in values for n. Okay, so if x is equal to pi n divided by k, and your k value is 1, it's just going to be what? Pi n divided by 1 would be pi n, and then you just have to plug in values for n. Do you guys remember what values we plugged in for n? One is one of them. So you're going to want to see them on the graph. So if you're plugging in values for the integer, you want things that are close to the origin. So the best values to plug in for n are -1, 0, and 1. When you're plugging those in, you don't have to show your work, but for this one, I'm just going to show you how to calculate them so you can do it on your own. So if it's pi times n, it's pi times -1, pi times 0, pi times 1. Okay, that's how you're going to find them. Okay, and that part should be really quick. It's just -pi, 0, and pi. Okay, so now we already have things that we're going to put on the graph. You have the asymptotes, you have the x-intercepts. The only thing that's left to find are going to be those nice points, okay, where if you plug in pi over 4, you would normally get 1. And for this, it says find where the graph is blank. I'm just going to say find another point on the graph. Okay, it can be where y is equal to positive or -1, and in most cases it is, but in this case, it's just a different a value. So find where the graph is plus or -1, unless a doesn't equal 1, then you're going to find where it's 1/4. Remember that when you plug in pi over 4, what do you get for the cotangent? One, right? At pi over 4, the cotangent's 1. So to find that other point, it's just pi over 4, comma 1/4. Another way you can think of it is if your a value is 1/4, you multiply the y coordinate by a 4. Okay, so your original point is pi over 4, 1. Your new point, you multiply by 1/4, is pi over 4, 1/4. And once you find this one, we're going to find the partner. Okay? We also are not going to scale the y's by 1/4. I want you to see what's happening because some of them are going to be narrower, some of them are going to be wider. Okay, so we're going to keep the scale here by 1. The only time you'll change the scale is if like your a value was 10 or 8. Okay, and then you'd have to make it fit on there. So this pi over 4 is letting me know that I'm going to want to scale by pi over 4 if I can. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This really is just your standard scale. Okay, and then when you are graphing, I recommend, I probably recommend for some of you to do your x-intercept first in pencil for your asymptotes in pencil. Because sometimes you will like get these that overlap if you made a mistake, and if that happens, right, you'll just have to double check your points. I always like to graph the asymptotes first. So the first one's at 0. So I do recommend using a highlighter for that. Okay, so it needs to be a dashed line. So it's at 0, it's at pi, it's at negative pi. And once you've done that, you've established a pattern. These asymptotes are going to occur every how many units on my graph, on your graph. Sorry, the green's a little hard to see. So even though I didn't write it down, I'm going to scale because they're every how many units? 1, 2, 3, 4. Every 4 units. I'm sorry, but that one, the green's a little hard to see. I'll use a different color next time. Okay, so when you're plotting your points, you have pi over 2. So this is 1 pi over 4. 2 pi over 4 is pi over 2. It should also be in the middle, in the middle, in the middle. Okay, and then when you're graphing this point, so you only have to write down 1. At pi over 4, I'm at 1/4. So here's pi over 4. I'm just going to go 1/4 of the way up. Okay, if this branch is going up from left to right, this branch has to go over 1 and then down 1 here. Okay, so this is 3 pi over 4, and that's going to be at negative 1. Okay, you don't have to write that point down. That's something that you'll naturally find, and we're going to keep doing that. So see how we went over 1 and then up to 1/4? Here we'll do the same thing. Over 1, up to 1/4. Go the other direction, down to 1/4. Okay, and cotangent does go down from left to right. Okay, take your time with these graphs. We know that with vertical asymptotes, you're not going to cross the graph. Okay, so don't get all jazzed up and start crossing those lines. Okay, I want you to just take your time, and you can do one branch and then the other. Yeah. All right, we ready for another type of transformation? So that one we did a vertical compression, okay? You tell me what kind of transformation this is. Okay, what type of transformation is this? Will you with me, buddy? Yep, it's going to the left, pi over 2 units. That is a phase shift. Okay, so my K value is 1. Okay, my B value is negative pi over 2. This is a phase shift. That is going to change my course of action here. So the first step is still finding the period where I'm doing pi over K. Pi over K is just going to be pi. Okay, if it's K is 1, it's just pi. Now, for the step before, I could just use all of the x-intercepts of the cotangent, but now everything's being shifted. So what can I do with those x-intercepts of cotangent? What's happening to every single one? Being shifted where? Pi over 2 units to the left. All we have to do is take the x-intercepts of cotangent and add the phase shift to it. So no matter what your phase shift is, just take the original. If all you have is a phase shift, you're going to take those original values and you're going to apply the phase shift. Okay, so again, we could look back at our table because it's okay if we don't have these memorized yet. By the time you're done with your practice, you will have a better handle on it. So be nice to yourself as you're figuring some of this out. And then when you're adding your phase shift, this is a negative. So you can write plus negative pi over 2, or you can just minus pi over 2. Okay, let's go ahead and do those calculations, and then can you box those in for me once you've done them? Okay, so if you have pi over 2 minus pi over 2, that's probably the simplest one to do to get your 0, right? 3 of pi over 2 minus pi over 2 is pi. And then here, negative minus a negative is negative 2 pi over 2, if you thought of it like that first, and then you canceled it out. Okay, so you have negative pi, 0, and pi. Those are your x-intercepts. Okay? Just like we did with this, you can take the asymptotes of the parent and then just apply the phase shift. So if your asymptotes are negative pi, 0, and pi, which again we can find from our parent graph, right? If I look at cotangent, see I have 0 pi, negative pi. I can just take those and apply my shift. So I can just subtract negative pi over 2 from each one. Okay, and then those are going to be where we're going to put our asymptotes. Okay, so if you have 0 minus pi over 2, you have negative pi over 2. Pi minus pi over 2 is positive pi over 2. Okay, and then the last thing we're going to do is find another point. When you're finding another point, remember that the nice point that we talked about is the cotangent of pi over 4. So we want whatever we have in here to be pi over 4, because if I take the cotangent of pi over 4, what's my output? If I plug in pi over 4, what would my output be? The cotangent of pi over 4 is what? What's the cotangent of pi over 4? All right, let's look it back up. The cotangent at pi over 4 is 1. The tangent at pi over 4 is 1. Okay, so if I want to figure out what I have to plug in for x to get pi over 4, you can really just set this equal to pi over 4 and solve. Or you just apply the phase shift to pi over 4. It's the same thing. Okay, so this is what can you plug in order to get 1 as your output. So you can get a common denominator, times 2 times 2, right? This would be pi minus 2 pi, which would be negative pi over 4. Which means your point is going to be negative pi over 4. And this is how we know this. If I plug in negative pi over 4 plus pi over 2, I get pi over 4. The cotangent of pi over 4 is what? 1. So this is going to be our other point. Okay, so you just have to find the one other point, write that down. The other ones will be on your graph. Okay? All right, so again, I'm going to go by pi over 4. So if I go 1 pi over 4, 2 pi over 4 is 3 pi over 2. When you're scaling by pi over 4, it is that standard scale here. Label here and here. Okay, and then with our highlighter, let's go ahead and put in the asymptotes. So the asymptotes are here. Pi over 2 is where one of them is. Negative pi over 2. And once you've done that, you've established your pattern. The asymptotes now occur every 4 units. So every 4 units, 1, 2, 3, 4, I'm going to put my line here. Okay, I'm also going to use my intercepts. So I have 0, pi. I can see that these are halfway. So I go 1, 2 units, you have an x-intercept. 1, 2, intercept. So always 2 to the left or the right of an asymptote. Okay, and then I have cotangent. So at negative pi over 4, I'm at 1, which means the other one is going to be at pi over 4. That's where I'm at negative 1. So you can write that down. You don't have to. You just have to graph that. Okay? And so this is going to help you with how narrow or wide each one of your branches is. And the branches really are like half of a parabola. That is why I'm graphing them like that. Because you have a curve here. And then this is just part of it in the window that we've created. Okay, again, remember it's not crossing those vertical asymptotes. Okay, we can take the time to make those quality graphs. But wait, there's more. What about this type of transformation? And we haven't done one yet that has a k value that's not 1. Behold, what is the k value for part C? 1/4. And then notice you also have this negative out front. Okay, this is a reflection. We'll talk about what that does to a tangent graph in a moment. Okay, you are going to be finding the period. So the period is pi divided by k. If your k value is a fraction, you're just multiplying by the reciprocal. So you have 4 pi. Okay, and now our step 2 process is going to change a little bit. Because if you have a different k value, this is called a horizontal stretch in this case, you have to use the reciprocal. Okay, so this is the x-intercept of the tangent, okay, multiplied by 1 over k. So if your k value is not 1, you are going to take the x-intercepts and you are going to multiply by the reciprocal of k. Okay, and that's because there's a horizontal stretch happening, so that does affect your x-intercepts. So let's look and see what our x-intercepts are of tangent. When we look back, we're going to see they're negative pi, 0, and pi. So if I multiply those by the reciprocal, I'm going to multiply each one by 4. That's going to give me my new x-intercepts. And you'll see that these fit the new period. Remember, now our period's 4 pi. Okay, so you'll have 4 pi in between those x-intercepts. And because our k is different, we are going to use our asymptote equation, because the asymptote equation already takes k into account. Okay, so if we look back here, the asymptotes of tangent are found by this. Pi over 2k plus pi n over k. So when you plug in k, you're going to create an equation that you can plug in values of n. Okay, so you're going to find your equation and then you're going to plug in your values of n into that equation. Okay, I know this looks complicated, but it's very simple. Once you simplify, 2/4 is 1/2. You divide by a fraction, you're multiplying it by what? Reciprocal. Okay, so this is going to end up being, the reciprocal of 1/2 is 2. Yep, so it'll be 2 pi plus 4 pi n. And then your n values, you can plug in -1, 0, and 1. And again, you can plug them in and show all your work for that. You don't have to. I usually plug in 0 first, because if you plug in 0, what do you get? 0 plus 2 pi. So I know 2 pi is one of them. Then I like to plug in 1 next, because that'll be 4 pi plus 2 pi, which is 6 pi. If I plug in -1, 2 pi minus 4 pi, -2 pi, and then you have your 3. Okay, so when you're doing your graph, you're going to have to just find your period, 3 of your x-intercepts, 3 of your asymptotes, and your other point. To find the other point, you can always take what the value is of, and we want that value to be pi over 4. Why do we want it to be pi over 4? Because what happens at pi over 4? Your output is 1, okay? And then you don't have to deal with all those decimals. So one way to ensure we're finding the right value is we can solve this with algebra. A lot of you are going to be able to find this without algebra, because what can you plug in for x that would make that pi over 4? 1/4 times what is pi over 4? Yeah, just pi. You can also multiply by 4, and you can simplify to get that, to get your x as pi. But what that means is when you plug in pi, your output is going to be, normally it's 1. Do you know why this one is -1 instead of 1? It's a reflection. So normally it would be 1. The only reason why this changes is because it's a reflection. Okay, so how a reflection works with tangent is the tangent of x normally looks like this. If you have a reflection, it goes the opposite way. Okay, this is the same thing as the cotangent. Okay, so the cotangent and negative tangent of x, they look the same. They're identical twins with different fingerprints. In case you guys didn't know that, now you know. Identical twins, they have identical DNA, but their fingerprints are different. Just in case you're an identical twin thinking about committing a crime. Okay, now I'm deciding to go by pies. That way I can go all the way up to 6 pi. I also feel like I need to say do not commit crimes, please. All right, and then we're going to put in our asymptotes. Okay, so we have 2 pi. Okay, we have 6 pi. And then you just keep repeating. So 1, 2. All right, and then when you are doing your intercepts, okay, you may notice, hey, every single time we've done this, it's been 4. Yep, that's because we're manipulating our scale. Okay, it doesn't always have to be that. So at pi, now I'm at -1, which means at negative pi, I'm at +1. Okay, and then remember, this is tangent, but because of the reflection, it does look like a cotangent here. Okay, and we can still get all of our points in there. All right, and then for part D, I want you to start by finding the period and then identifying those transformations by telling me what those values are. Okay, so find the period. You don't need me to find the period. Okay, so what is your K value? Okay, I know this is definitely complex, but I also know you guys are very smart and you are very capable of doing this. Okay, I wouldn't give you anything that I don't think you can handle. So your K value is 1/3. The other thing we should find is our B. Our B value is what? Pi/2. We got a phase shift in this house. We got to shift it over. All right, so your period is pi divided by 1/3. When you divide by a fraction, you gotta flip it. Oh, now I'm paying attention. Okay, and then I asked you to think about how you have. Hey, next year you're gonna be happy. You're good. I want to go back to the days when I used to just graph those tangent functions. When you are thinking about how to find the x-intercepts, okay, for the last few times we've been taking the x-intercepts of the parent, and we have 2 transformations here. Our K value is not 1, but we also have a phase shift. So our K value wasn't 1 here. We had to multiply by the reciprocal. We had a phase shift here. We had to add the phase shift. Okay, this is going to be twice the fun. Which should I do first? Should I do the multiplying or the adding? Multiplying. Follow your order of operations. So you're going to multiply by the reciprocal. Stay strong. Okay, we can do difficult things. I know it. Okay, so once you have the x-intercepts, let's go ahead and let's apply that reciprocal function. So when you flip it, you're going to multiply by 3. When you multiply by 3, easy peasy lemon squeezy, we got -3 pi, we got 0, we got 3 pi. Now we got to apply the phase shift. Okay, the phase shift is just adding pi/2. Okay, if we're adding pi/2, if you need to, we can get a common denominator. and we can find what that value is. So times 2 times 2. This would be negative 6 pi plus pi, which is negative 5 pi. So negative 5 pi over 2. Yay, we're adding 0. We like that one. And then here, we're going to multiply by 2, multiply by 2. So 6 pi plus pi, 7 pi over 2. Okay, those are your x-intercepts. For the asymptotes, this is something that we haven't had before. We haven't had the transformation and the phase shift, which means you have to take that equation that they give you and you got to add that phase shift. Okay, so the equation is pi over 2k plus pi n over k. Okay, that's your equation for the asymptotes here. But now we have to add in the phase shift. So if I have pi over 2 times k plus pi n divided by k plus my phase shift of pi over 2, I can simplify. Okay, so k is 1/3. I'm going to plug in 1/3 and 1/3. And remember, instead of dividing, just do the reciprocal. What's the reciprocal of 2/3? 3 over 2, so it's 3 pi over 2. Reciprocal of 1/3, 3. So 3 pi n plus pi over 2. Okay, now we do have some like terms here. So to make this a little simpler, we can just add those together. What's 3 over pi over 2 plus pi over 2? 2 pi. And then, again, you can do this mentally where you plug those in. I like to do the 0 first, because that will just be 2 pi. The 1, 2 pi plus 3 pi, 5 pi. Negative 1, 2 pi minus 3 pi, negative pi. Okay, whenever you are trying to find that last point, all you have to do is look and see what the tangent is of. You always want the tangent to be of pi over 4. So you can just take whatever you have here and set it equal to pi over 4, and you can solve that. Some of you might just be able to do that mentally. That's fine too. For one like this, I recommend multiplying by 3 first, because that will cancel. This last one does have a lot of steps to it when you have the multiple transformations. Okay, so when you're adding 3 pi over 4 to pi over 2, you just need a common denominator. So 3 pi plus 2 pi is going to be 5 pi. Denominator stays the same. You can always verify by plugging this in. If you plug in 5 pi over 4 and you subtract pi over 2 and then you multiply by 1/3, you will get pi over 4. And anytime you do the pi over 4, you're going to get 1. Okay, so this is going to be a point on your graph. Now normally I would like to go by pi over 4, but I need to get out to 7 pi over 2. So I'm going to have to go by pi over 2 and use the halfway marks. So this would be 1 pi over 2, 2 pi over 2, 3, 4, 5 pi over 2. You're going to see I like to label where I'm going to be putting some of those important values. Okay, and then let's put in our asymptotes here. Okay, so pi over 2. Oh, I did it. Remember I told you guys what you're going to do sometimes? What I do. This example is sponsored by Mr. Penn. I think I broke Mr. Penn. Okay, so negative pi, 2 pi, so this is 1 pi over 2, this would be pi, this is going to be 2 pi, and finally we have a different scale, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, don't have room there, 1, 2, 3, 4, 5, 6, okay, and then for your intercepts, at pi over 2, at 7 pi over 2, and at negative 5 pi over 2. Okay, at 5 pi over 4, 1. If this is pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, so if this unit is over 1.5, it's just going to go back 1.5. Sorry, 1.5, which is here. Okay, so same thing here. 1.5, there you go. 1.5, there you go. Okay, if you did not pick up a graph sheet, you can do that today. Okay, in order to get full credit on your homework, you do need to make sure that you're doing all your steps. And then your homework is not going to be due until Monday. Okay, you can see your homework on the calendar.